The Orion XS 50 amp DC to DC charger is finally on the market, but more importantly is in my hands. And so we are going to do an unboxing and testing, specifically heat testing of this unit to see actually how much better it is than the old Orion Smart 30 amp DC to DC charger. So let's get into it. So right out of the bag, it is very apparent how much smaller physically the new Orion XS is than the old Orion Smart. And it's kind of crazy considering that this is a 50 amp charger and this is a 30 amp charger. So nearly twice as much charging power as the old model. So significantly lighter, way thinner, there's no heat sink on the back, and just all around kind of a weird concept to think that this little guy has so much more power. Now, the first thing you may notice is on the front says the buck boost, the smart buck boost there. And this is an early release. By the time these actually end up on shelves, it's going to be called the Victron Orion XS. So in order to not confuse anybody, I'm going to fix it. And problem solved. We now have an Orion XS 50 amp DC to DC charger in hand. So for the rest of this video, we're just going to refer to this one as the Orion XS and the Orion Smart, although this has smart features. The other things that we need to notice about this are, let's see, check my notes up there. Small, thin, light. There's no heat sink on the back because this doesn't get as hot as this, because this has an efficiency rating of like 97%, 98%, and this is like 87%. So efficiency loss comes with heat gain. So since this is way more efficient, should have a lot less heat loss, which we'll test later in the video. The other things to note on here are the size of the terminals. Since this is only a 30 amp charger, the terminals can fit up to 6 gauge wire, and the terminals on the Orion XS here, they can fit up to 4 gauge wire. Now with the terminals, the thing to note here is that there's this little cover on the front of the Orion XS that comes off to reveal the actual screw terminals right in here. And these terminals are sized to accept up to 4 gauge wire, which I've heard some reports of it not fitting, but the wire that we will be selling in the kit for this Orion actually does indeed fit just fine. Now this cover is not necessarily just to conceal the terminals, but it also adds a little bit of strain relief because there's this bar on the inside of the terminal cover that sort of clamps down on the insulation of the wire once these screws are tight. And although I do think that adding an additional clamp right below the Orion for wire strain relief is always a good idea, having a little extra strain relief inside of the unit is always a welcome thing and is a pretty cool little idea there. So the other good things to note about this is it still has the same remote port here on the side that you could wire a switch on this bridge to turn the unit off and on from a manual switch if you wanted to, although you can do that with the Victron Connect app. That same functionality was here on the old Orion Smart as well. This one has a VE.Direct port, so this will be able to communicate with the Serbo GX or the Chrono GX or any of the other GX devices from Victron, so we can visualize its flow of power and how much power it's contributing to recharge a battery bank. And the last thing I want to note is there is no equipment ground on the new Orion XS 50 amp, like there is with a lot of the charge controllers, but ultimately there wasn't an equipment ground on the Orion Smart either, so maybe not really matter, but it does make for wiring, makes it a little easier. So now I'm going to get rid of this wire because it's bothering me, and then we're going to talk about communications of the unit. Communications on the Orion XS is going to be in a couple different ways, and the first way is through VE.Direct to a GX device like the Serbo GX or the Chrono GX, so we can see it on a nice screen inside of our camper or as well as on the VRM portal. Now, I can't show that to you in this video because as of today, January 23rd, the firmware for the GX devices has not been released that is going to allow us to show all of you that function. So you may stay tuned to social media, follow explorist.life because I'll probably be showing that in a few social media updates later on. That should be released to the public in early February and released as a beta test in this weekend, which is like, I don't know, like what, the 28th or something like that. The other way that we're going to be able to do communications with the Orion is through the Victron Connect app, which is already live and it's functioning just as it should. And I've got a little screen recording that I can show you that it's going to show up just the same as all of the smart solar charge controllers they have. So it's going to show you the input voltage, the input amperage, output voltage, output amperage, and all that good stuff, and that's already live. The other communication protocol with the Orion is VE Smart networking, which is going to allow multiple Orions to communicate and coordinate their charges with each other, as well as communicate and coordinate their charges with Victron Smart Solar MPPT solar charge controllers. So if you're charging from your Orion at 50 amps and you've got a solar charge controller that's putting out 30 amps, you know, while you're still driving down the road, because solar panels still work while you're driving, that's going to communicate all of that information through VE Smart networking and allow you to charge at up to 80 amps in that particular scenario. But that functionality, as of today, January 23rd, is not available, but that will be released in a firmware update in the near future, hopefully by the time that these hit these shelves in the USA. Now, on to the heat test, which is probably realistically why all of you are still sticking around. Heat testing is important for both of these units because there have been just an absolute ton of comments about this unit getting way too hot, which it definitely does get hot. You know, it's not so hot that it's going to burn the van down. You know, if things get that hot, you know, the other things have gone seriously wrong, but it's definitely uncomfortable to not be able to have your hand on this thing while it's actively charging. Some people have even resorted to using fans and such behind the charger to keep it cool, which is fine, but you know, you don't want to have to do that once you've bought an expensive piece of equipment. And the Orion XS, it boasts a 98% efficiency rating, which should mean that there's less heat output. And I actually just finished up the testing of this just right over there, and I'll show you what I did, how I set all that up, and then share the results with you. Here is the tabletop test that we have made for this particular test. So we have two 12-volt battle-born lithium batteries right here, wired in parallel to form a 12-volt battery bank through proper fusing through a Blue Sea safety hub up top, as well as a Victron Smart Shunt. We've got our Victron Blue Smart charger for charging from a 120-volt wall outlet there, as well as a Phoenix 12-volt 800 VA inverter right here for discharging the batteries. We have our Orion XS right there, as well as our eChrono for monitoring, and then our alternator. And we used this because we didn't have space to fit an internal combustion engine complete with alternator right here. So we're just using this for testing. So instead of the alternator being powered from the internal combustion engine of a vehicle, it's being powered from just a standard wall outlet. This is going to deliver a constant 12 volts at up to 100 amps to our Orion. So that's the equipment that we used. Now here is the flow of power and how we actually tested it. For our testing, we recharged the batteries all the way to full from a wall outlet with this charger, and then we needed to give the Orion some room to work, which meant we needed to discharge the batteries. So we used the Phoenix inverter to discharge the batteries from 100% down to 20% so that the Orion could pump some power back into the batteries. We used the alternator here, turn the switch on, which delivers up to 100 amps to the Orion right there, and then goes into the batteries. We let this test run for 1 complete hour, starting with no power, and we monitored both the Chrono GX as well as the temperature of the units through this FLIR camera, thermal camera that just attaches to my phone. We let this test run for 1 hour and monitored the results every 10 minutes. And here are the results. Both units started at 48 degrees Fahrenheit, and after 10 minutes, a large increase was seen as both units started generating power, with the 30 amp Orion Smart jumping to 77 degrees and the Orion XS jumping to only 59 degrees. After 20 minutes had passed, the Orion Smart 30 amp charger jumped to over 100 degrees and the Orion XS was still only at 80 degrees. The 50 amp Orion XS didn't reach 100 degree temperatures until 50 minutes into the test, where the 30 amp Orion Smart was already at 137 degrees. And finally, at the conclusion of our 1 hour test, the 50 amp Orion XS seemed to hover right around the 100 to 105 degree mark for those last 20 minutes, where the 30 amp Orion Smart reached temperatures of 143 degrees and was still climbing. So the tests were, fortunately, as I expected, just being able to view the data sheets and stuff like that from Victron ahead of time. I knew this was going to run cooler, but hopefully that exercise kind of shows how much different it is. 143 degrees, I couldn't keep my hand on the front of the Orion very long, and at 100 degrees, I could keep my hand on the front of this Orion for, an indefined amount of time. I could do that forever. Now, I will note that the back of the Orion, it did get quite hot. This is the heatsink here. That is basically the same as this. It's obviously much smaller. But the thing is on this is going to get hot, but it's not actually touching anything. These feet on the charger here, it's the same plastic as the front of the charger. And so, on the Orion Smart, the mounting points are built into the heatsink. And so this part back here gets really hot. Whereas the parts where it's going to be touching the wood or whatever it is that you're mounting this thing to doesn't really get hot. And I was able to see that in the thermal camera where we moved the charger away from the table, and the table only got up to like 80 something degrees because of the heat radiating off of this, which is, realistically not a problem at all. And aside from the physical, heat being uncomfortable to touch thing, these units, as they get hotter, they're going to put out less power. They have various derating factors, and, as this gets hot enough, it's going to say, hey, we're only going to put out 90% in an attempt to cool itself. And you can kind of see that on the results page as well, where it went from putting out 360 watts at the start to putting out, 320 watts near the end. It had derated in an attempt to cool itself down. So it is just kind of wild that the fact that this is putting out, more power, but is actually running, nearly 40 degrees cooler. That's kind of a wild concept to me, and just kind of goes to show you how much engineering they put into making this thing run cooler. Now, you may be seeing the fact that this has a 700 watt rating on the front of it, 50 amp, 700 watt. And you'll also notice that on our results screen, we never saw this get up to a 700 watt output. And instead, the most we saw was in the 550 watt range. And let me explain why that is and why that's probably worse results from our tabletop demonstration, but you're probably going to see better results in a real-world application. Let's just get this out of the way for a minute. So the reason that we didn't see the full 700 watts out of this is because the DC power supply that we're using supplies a constant 12 volt output, which after a little bit of voltage drop meant that we were getting 11.8 volts to the inputs of the Orion. Now this Orion XS is going to limit both the input and the output amperage to 50 amps. So it can't draw more than 50 amps on the input side to make up for voltage drop. And this particular unit we'll only see 700 watts of output whenever the incoming voltage is 14 volts, because 50 amps times 14 volts is 700. And so if we're not getting 700 watts of input, we're not going to get anywhere near 700 watts of output. So if my alternator simulator, aka DC power supply, was supplying 14 volts to the input terminals of this, we're going to see a lot closer to 700 watts on the output side. So during this test, what we were seeing with those, 500 whatever watts is we were seeing the 50 amps that is current limited through the Orion being delivered at 11.8 volts from our DC power supply that's, remember, simulating the alternator. So it's delivering 590 watts, which this is operating and was operating, we saw it through the app, at 98% efficiency, which means that the 590 watts coming into it is only going out at 578 watts. So you're losing a little bit of wattage just through the conversion process, but it's still really, really, really efficient. So those 578 watts were being delivered at 13.5 volts to the battery bank, because that's just where the bulk state of charge was for the batteries at that time, which resulted in 43 amps being delivered to the batteries, which all of those figures are going to change depending on what the incoming voltage is being delivered from the alternator, as well as what the battery bank voltage is. Now, I know that was a lot of math, and it's kind of hard to visualize, what you're going to actually see out of this Orion. But, even on that test, I would say is a worst case scenario. And, we're still getting, over 40 amps out of this 50 amp charger. The other thing I wanted to talk about that's a non-math thing, because I'm tired of talking about math at this point, is the heat testing. We had everything facing down like this. Now that is against manufacturer's recommendations, but realistically I wanted to put both of these units at a mechanical disadvantage, because nobody is installing any of these according to manufacturer's recommendations in most cases. These are all made to be installed vertically, so the heat can rise, because that's how heat does, right off the backs of those heat sinks. So we probably wouldn't actually see temperatures as hot as we were if these were mounted vertically, but I did want to create a little bit of a disadvantage for these units because we're kind of stress testing it, and I didn't want to put these in, kind of their best thing, just to make them work just a little harder. So I'm really happy with how the results of this test came out, and I need to know two things from all of you. First thing I need to know, what other testing do you want me to do with this? There's probably some more features that I haven't quite covered, and I need to know from all of you, what do you want to see covered on this unit? So leave those down in the comment section below. The second thing I need from you is, I just kind of want to get everybody's thoughts on if a 40-degree Fahrenheit temperature difference from this less powerful unit to a more powerful unit would be worth the cost of an upgrade. I think it would be, but I also am just curious of what everybody else thinks. So leave that in the comments below. Thanks for tuning in, and we'll see you next time. Oh, you know what I need? I need duct tape and a Sharpie. So right out of the bag.
Sorry.
What? And jump cut to me having another screwdriver. I don't know what to do with my pen. So I'm a big fan of how these results actually turned out, and I need two things from all of you. I need to know something.